Now next question is, wrote this: if v is equal to cos x, find average velocity for interval pi upon 2. Theta, this is a theta given. Theta is given. Question is saying if a v is equal to cos x, x is performing as a theta. Find average velocity for interval this. Okay, theta can be equal to 0 till the 90. Till the 90. So rather than taking one by one, we can take from 0 to pi upon 2. So our average velocity will be this 0 pi upon 2, and v is how much? V is cos x into dt upon pi upon 2 0. So this will be dt hour. Depreciation of dt will become t. Okay. Now this cos x from 0 till the pi upon 2 t pi upon 2 0 pi upon 2 0. Finally we have did integrate. So integration of cos x will become sin x. You know, integration of cos x will become sin x. Integration of dt will become t. First of all, we will put a value of 0. Then this will become 0. Now pi upon 2 sin pi upon 2 upon pi upon 2. Okay. Then sin 90 will become 1, and this is our pi. So 2 upon pi is our answer. This is our answer. Integration of cos x will become sin x. Then value of sin 0 is 0. Sin pi upon 2 will be 1, and just we put this t as a pi upon 2, and this 2 went upward. Then finally we got to 2 upon pi as a result. Now let's move ahead next towards topic. Okay, next topic is acceleration. Definition is very simple. Rate of change in velocity. Change in velocity will be our definition of acceleration. Change in velocity is known as acceleration. Unit will be meter per second square. This is our unit. Now when it comes to quantity, then this is our vector quantity. This is our vector quantity. Now next, can it become positive, negative, or zero? Yes, answer is yes. It can be positive, negative, zero. Clear? Now, formula, what would be formula? For acceleration, formula would be change in velocity. Change in velocity. So to calculate change in velocity, we will have to take what initial and final. So final minus initial will give us a change in velocity upon total time. Okay? This is our formula to calculate simple acceleration. Now let's come to the types of acceleration. This was about definition of acceleration. When it comes to types of acceleration, then we start from one, which is known as this first, instantaneous acceleration. Remember, whenever instantaneous word is coming, just understand that it is talking about the current aspect. Okay. So, what will be definition? Acceleration at a particular time is known as instantaneous acceleration. No, velocity, change in velocity at a particular time is our instantaneous acceleration. Okay. So for this formula is nothing but inst is equal to dv upon dt, where v is our vector. This is formula for instantaneous acceleration. Now second, we have uniform acceleration. So you need to understand over here is that uniform means equal, acceleration is equal, means velocity is a constant. There is no change in velocity. Is known as uniform acceleration. So magnitude and the direction both will be same. For example, acceleration is 5 meter per second raised to power 2. It will be continue 5. Now over here direction will be one direction. If it is a state, so state will be for all time. For non-uniform acceleration, magnitude will be changing. Either magnitude will change or direction, anything can change. Okay, either magnitude or direction will change, will be our non-uniform acceleration. Okay, will be our now next average acceleration. Average means total. Average acceleration. It is represented by this A. This thing is used for average, for total sign. So you would say change in total velocity, delta V and delta T. Delta means total. Okay. Whatever will be direction of velocity will be also for acceleration. This is one point to remember. whatever will be velocity of whatever will be direction of velocity will be for also direction for acceleration. Okay, now look at over here. Instantaneous acceleration is equal to dv upon dt, but remember, when v in function of a time. Okay, what's the difference between them? Over here, dv upon dt into ds upon ds. We have seen this thing, okay, but not this thing. Just we applied this one more thing, which is valid for this. So ds upon dt, can you change this over here and this over here? Then it will become dv upon ds into ds upon dt. Okay, dt. So ds upon dt is a velocity. Okay, dv into d upon ds. It can be written like this. Clear? But we will use this formula when time is not given. When we find there is a function of a position. When time will not be provided by the equation, then use this formula, where v is the velocity and s is a displacement. Clear? S is a displacement. Important points. Important points. First is, when particle moves with a constant velocity, then its acceleration will be 0. Remember, when particle moves with a constant velocity, then our acceleration will be 0. Clear? Our acceleration will be 0. Why? Because there is no change in velocity. Velocity is fixed. That's why. So this was one part. Velocity is fixed, which is a constant, and there will be no acceleration. Acceleration will be considered as a 0. Next we have, if a particle moves with a constant velocity, if a particle move with a constant velocity, then speed will be equal to mode of average. We are talking about this is a speed, this is a velocity, average velocity. Average velocity. This will be equal to this speed will be equal to mode of average velocity. Okay. Then this will be equal to instantaneous velocity. Instantaneous velocity and mode of average velocity. Mode of average, not average but instantaneous velocity. Instantaneous velocity. Okay. Clear. Try to understand. Till here this is correct. Correct. This should be separate part, isn't it? This should be separate part. Now next point. A particle may have variable velocity but constant speed. For example, uniform circular motion. Uniform circular motion. A particle may have variable velocity but constant speed. Uniform circular motion. Over here, a speed is the same. A speed is a constant. A speed is a constant. Next we have acceleration, which opposes the motion of body, is known as retardation. Opposite of acceleration will be known as what? Acceleration, which oppose the motion of a body is our retardation. Retardation will give us negative retardation. Now case number 1. If v velocity and acceleration are same direction, then a speed increase. Over here, case number 1 is if a velocity as well as acceleration both are same direction, then a speed will increase. If the direction is same, of course, yes, a speed will be increasing continuously. Okay, so here you would say velocity will be equal to, this velocity will give us positive, direction will be in this same, and acceleration will be also positive because the direction is the same. Second thing, if a direction is opposite, first of all, if a direction is opposite, in that case our velocity will be negative, so acceleration will be also negative because of reason is the direction is opposite, both are in this direction. Case number 2 over here. Case number 2. If v and acceleration are in opposite direction. Opposite direction. Then the speed will decrease. Will decrease. Means if velocity is in this direction, the acceleration is in this direction, in that case speed will decrease. Speed will decrease. Vehicle is going in this direction. When external brake will be applied, then what will happen? Retardation will come into picture. Retardation. This will be minus v. Okay, minus v. Second, if a velocity is in this direction, this will be our negative, and acceleration will decrease. Acceleration will decrease. Acceleration will decrease. Okay. Here acceleration is decreasing. Why? Because velocity is acceleration is increasing. Velocity is decreasing. When velocity will be decreasing, then this will happen. This will happen. Now next. Now equation of motion. Equation of motion. There basically there are three equation of motion, but two will increase more. These are valid when acceleration. Yeah. These are valid when acceleration is constant. When acceleration is a constant. Clear? We will use this formula when acceleration is constant. Acceleration is constant. So a scalar form, and this side vector form. First equation of motion is v is equal to u plus at. We can write, you can convert this form into vector form. How convert? So v is initial velocity, okay, is equal to v is this v was final, u is initial, a is also vector, t is not vector. Okay, t is not vector. Second equation of motion is s is equal to ut plus half at square. So s is a vector, u is also vector, but t is not vector. 1 by 2 will be as it, a is a vector, t is not vector. Clear? Next, third, v square is equal to u square plus 2as. Not the plus, yes, 2as. So this will become u square plus 2 and s. Yes. One more for snth. U plus half a n 2n minus 1. We will use this when question is asking nth time, nth displacement. Calculate this nth displacement. Then we will use this formula. So Snth then equal to u vector plus half a vector 2n minus 1. This is the in vector form. Remember here u is a initial velocity, v is a final velocity, t is a time, s is acceleration. Okay. Ascent is displacement. This is also displacement, but in 1 second, in 2 seconds, in nth second, here time will be fixed. Okay, we have seen this three equation. Again, v is equal to u plus at. This is first. Second is s is equal to ut plus a half at square. Third is v square is equal to u square plus 2ac. We can convert this into vector form. And fourth was snth is equal to u plus a half at 2n minus 1. a into 2n minus 1. Now derivation. Let's see derivation. First. We know a is equal to dv upon dt. But how? How did it come? We know that a is equal to dv upon dt, but how? Let's see derivation by the help of calculus. So you know, from initial to final, dv is equal to from 0 to t. It is equal to a dt. Just dt came here, and it became dv is equal to a into dt. So time is from 0 to t, and from initial velocity to final velocity. A dt. And from here we will get v minus u is equal to at. From here, at will be as it, and we know dv is nothing but v minus u, v final minus initial, and this will be 80. Okay, v minus u came from initial minus initial. This is a final minus initial. This was the first derivation. Now let's take a question answer. Now let's take question answer. Question is find out the distance and displacement displacement. Where figure is like this. This is figure. This is our figure. But remember, this is one area, area 2, area 3. Three areas. There are three areas. There are how much? There are three areas. So it is asking distance and displacement. So answer would be answer would be total distance. Total distance will be equal to area of a city, not a city but VT curve. VT curve. So when it comes to distance, just we add all the actual parts. This A1 plus A2 plus A3. This is our total distance. When it comes to displacement, then we say that A1 is positive, minus A2 is negative, and A3 is a positive. This is our total displacement, because this part is coming in negative section and these two parts are coming in positive section. Okay, in positive section. That's why. That's why. Now next question is various the variation of velocity of a body moving along a straight line is shown in following figure. The distance traveled by the body is in 12 seconds is figure is like this. This is figure. Witty graph. It is a witty graph. If you take this parallel, this perpendicular, we get x as a 2 and 6. This is 4. This is complete question. Question is asking the variation of velocity. Variation of velocity. This velocity, this velocity, this velocity of a body along a straight line is shown in the following figure. The distance traveled by the body. Distance. This distance traveled by the body in 12 seconds. In this much second. This much second will be how much? And body traveled like this. Okay. Of course, it is asking complete distance from 0 to 12 seconds. You know, it is a Vt graph. This is a Vt graph. So this will become ds upon dt. From here, it is asking nothing but total distance. When it comes to total distance, we use integration. So this will be d into dt. Integration. Limit is from 0 to 12. For distance, it is very simple. Just we add all. This is a1, a2, a3, a4. This is a1, a2, a3, a4. We don't need to go from 12 because it is not compulsory by the equation. So distance will be a1 plus a2 plus a3 plus a4, where a is area. Okay, you can see, brother. You can see. This a1 is a triangle, a2 is a square, a3 is a triangle, a4 is also triangle. Only a2 is a square. a2 is a square. So a1 is a square. Can you write 1 upon 2 base multiple altitude, where base is a 2 and altitude is a 5. That's why. So a1 will give us area. So 1 by 2 multiple 5. So finally a1 came as a 5. Okay. So a2 is what? A square, not a square but rectangle. 5 multiple 4, 20. Yeah, 20. This will be 20. A3 will be nothing but 1 upon 2 multiple what over here. This is a 10, remember. So this will be 4 multiple 5, 4, so 10. A3 is a 10. A4 will be 1 by 1. We are calculating a1, a2, a3, a4. Then at the end we will take all this together. So a4 is again triangle. So over here base is 2 and altitude is minus 2.5. 1 by 2 multiple 2 minus 2.5. Okay. Right now we are ignoring what this minus. So finally we got 2.5. Area of fourth section is 2.5. So total distance would be a1 is 5, a2 is 20, a3 is 10, a4 is 2.5. 30, 35, 37, 37.5. This is a complete distance. This is our answer. What did we do? Either you can use this formula from 0 to 12, but V was not given. Figure was like this. That's why we used different method. Now next question. For the velocity time graph shown in figure, below the distance below the distance covered by the body in last 2 seconds of its motion is what fraction of the total distance covered by it in all the 7 seconds. All these 7 seconds. Graph is something like this. VT graph. VT graph. This is our graph. This is our graph. For the velocity time graph for this given figure, by the body covered by distance covered by the body in the last 2 seconds. In this 2 second, its motion is what fraction of the total distance covered by it in all these 7 seconds from it. First of all, let's find this A1, A2, A3. A1 will be nothing but 3, 1 by 2 multiple 3 multiple 10, 2 5s are okay. So 5 3s are 15. So A2 is going to be 2 multiple 10, 20, and A3 is going to be 2 multiple 1 by 2 upon again 15. So total from it, total is how much? Total area is area under curve under under curve is 15 plus 30, 30 plus 20, 35, 30, 20, 50, 50 meter, 50 meter. But the question is asking last 2 seconds, in this 2 seconds. So A3 will become, this should be our answer. Okay. Last in 2 seconds. Distance covered by last 2 seconds. Last 2 seconds upon total distance. Total distance. This is 15 and total distance is 50. 50. So answer will come as a A3 is how much? 1 by 2 multiple 10. So this is a 10. This will become 45. And over here, this is our 10 by, so 1 by 5. 1 by 5. But hold on, this is 40. This is 40. Why? Because of this. Because of this. So 1 by 4. 1 by 4 is our answer. 1 by 4. Distance covered by in this is a 10 meter and total distance. Just we subtracted from this total not subtracted, and this part we took. Now next is in time interval. From 0 to 8 seconds. Figure is like this. This is figure. Two, 4, 6, 8. 2, 4, 6, 8. Try to understand. Here find the distance and displacement in time interval from 0 to 8 seconds. This will be our A1, A2, A3 and A4. A1 will be, let's assume A1 will be 2. 1 by 2 multiple 8, not 10. So this came as a 10. A2 will be A2 2 multiple 12, 24. A3 will be A3 1 by 2, 2 and 8. So 1 by 2, 8, 8. Okay. A4 will be our 2 multiple 10, 20, 20. So finally, distance is going to be, first of all, distance will be total A1 plus A2 plus A3 plus A4. Okay. A1 is 10 plus 24 plus 8 plus 20, which is 10, 30, 50, 62. 62 is a total distance from this figure. Okay, from 0 to 8 seconds. Now, when it comes to displacement, here is a little bit different. First of all, this is increasing. Whatever is a positive, just we will add. A1 plus A2 minus A3 plus A4 plus A4. So value for A1 is 10, A2 is 24, minus A3 is minus 8, A4 is 6. A4 is how much? 20. So 34, 54 minus 8 will be our 4 and then 46. 46 is a displacement from this equation, from this figure. 46 is a displacement and 62 was a distance. Okay, that is how you will calculate. This is our answer, final answer. Figure was like this. Figure was very simple. Figure was very simple. Very simple. Now next question is next question. Mahesh begins to walk eastward along just understand by the figure. Figure is like this. This is figure and over here 20 is over here. This is 15, 10, 5, 0, 20, 40. Kishan is asking average speed. Average speed. Average speed. You know, it doesn't matter Average speed does not care about the negative. It will take negative as a positive. So this will be our A1 and this A2, A3 and this is our A4. So total distance is how much? Total distance. Total distance is how much? For this we have 40. For A1 we have 40. For A2 we have again. For A2 here slope is 0. Slope is 0. Okay? Yeah, 0 because of constant. For A3 it is a decreasing. So minus. But we are talking about average speed. So how much? We would say 40. Again how much? 20. Again 20. Upward 20. Total time is how much? 20 second. 20 second. 20 second. So 40, 100, 80, 100, 120 upon 20. So 2 6 are 12. So 6 is our average speed. 6 is our average speed. Clear? Average speed. We didn't care about negative section. But when it comes to average velocity, we will care about the negative section. Okay, negative section. Negative section. Next question is over here. Equation of displacement. Equation of a displacement for any particle. Is how much? S is equal to 3t raised to power 3 plus 7t raised to power 2 plus 40t plus 8 meter. Its acceleration at time t is equal to 1 second is how much? Okay, read this question carefully. Equation of a displacement for any particle is S is a displacement 3t. Acceleration at 1 second will be how much? How much? Look at over here. Equation of a displacement. This is equation. Yeah. Equation is S is equal to 3t raised to power 3 plus 7t raised to power 2 plus 14t plus 8. This is the in meter because of a displacement. Its acceleration. It is asking acceleration. What will be acceleration at 1 second? At 1 second. Whatever is given by the equation, you can write first of all. Okay, S is given 3t. Okay, plus 7t square plus 14t plus 8. M is a meter. Now, we know ST is the relation of velocity. ST is the relation of velocity, where S is a vector dt. So depreciation of t raised to power 3 will be nothing but 3 3 is 9 t square plus 7 2 is 14 t plus 14 Okay, this is our velocity. Now acceleration is what? dv upon dt, where v is a value, this much. We are calculating acceleration because it asked acceleration at 1 second. So again we are going to differentiate this one more time. So this will become 18t plus 14. Okay, no problem. Now at t is equal to 1 second, what is our acceleration? At t is equal to 1 second, what is our acceleration? So it is very easy. 18 ones are 18, 18 ones are 18 plus 14. A is coming as a 12 3, 33, 32 meter per second raised to power 2. This is our answer. This is our answer. Yeah, this is right.